Good morning, students. This is the very important lecture of your syllabus. It is not only connected to vectors, but almost 7 to 8 chapters of your physics syllabus. It will help you in motion in one dimension. That means when the body is moving along a straight line or along a curve, right? Then it is going to help you in motion in 2 dimension. Motion in 1 dimension, sometimes in NCERT books is written as motion in a straight line also. Motion in 2 dimension means it is either circular motion or it is rotational motion. That is motion in 2 dimension. Then it will help you even in the chapter projectile motion. Then very lengthy chapter of your physics syllabus, NLOM, that is Newton's laws of motion. Then it is going to help you in the chapter friction also, right? So it is going to help you at least in 7 to 8 chapters of your syllabus. So the first concept which we are going to study is concept of normal reaction force. Then another equivalent important article is concept of tension force. Again, both these articles go hand to hand. Then in between I am going to teach you what is the meaning of buoyant force, right? Archimedes principle, what you have heard about in school. And then it is going to be concept of normal reaction force again, right? What do you feel when you are inside a lift, right? You simply need a weighing machine, that is portable weighing machine. That is portable weighing machine. So you are going to learn about this also. Just keep checking this is on, right? Okay. The first article. Suppose this is a horizontal surface. This is a horizontal surface and there is a body lying on it. Suppose this is yourself. Maybe you are sitting on a bench or maybe I am standing on the ground. So suppose this is myself. Then do you agree with me? My weight is always acting vertically downwards. Do you agree with me? My weight is always acting vertically downwards. What do I mean by that? Whether I am holding the body this way, right? Then also it comes down vertically like this. Then if I am holding the body this way, it will not go down like this. It will still come down like this. If I am holding the body this way, then also it will come vertically down like this. It's something like I am jumping from the mountain, right? So I will go down like this, right? Somebody is holding me and releasing from the mountain top, right? I will still go like this. No, I can't go like this. So remember, weight is always acting vertically downwards. Don't say downwards. W is weight and is always X. X always vertically downwards. Now we know that to every action there is an equal opposite reaction. So over here, when I think about the force exerted by this surface, this is the horizontal surface, on the body, it will be in upward direction. And it is normal reaction or else simple reaction or else normal reaction. And mind you, this force is always acting at right angles. Very important. Very important. Whichever way I am holding the body, weight is always acting vertically downwards. But if you think about normal reaction force, the normal reaction force is always acting perpendicular to the surface on the body. That means if this is the surface, then normal reaction force is like this. If the surface is tilted, it's not necessary that you are walking on a horizontal road. Maybe you are walking on an inclined plane. Maybe you are going for the mountaineering, right? Maybe you are going for trekking. That means you are going this way. Then in that case, the normal reaction will be this way. If you are going on a horizontal surface like this, normal reaction is this way, right? But if you are going on an inclined surface like this, normal reaction will be this way. Mind you, weight is still going to be vertically downwards only, right? That means if you are like this, weight is vertically downwards. If you are like this, weight is still vertically downwards. If you are like this also, that means if I am holding this body, suppose I am holding this body, I am holding this remote control. The weight of the remote control is like this, correct? Then I am holding this remote control like this. Still weight is like this. I am holding it like this. Still, when I just release my grip, when I loosen my grip, will it not fall down this way only? It cannot go this way. So remember, weight is always acting vertically downwards. And what is the meaning of N over here, or what is the meaning of R over here? It is normal reaction force, which is our title. It is normal reaction force, and it always acts. It always acts perpendicular to the surface. It always acts perpendicular to the surface. What is the meaning of weight? Weight is the force by the body. Weight is the force by the body on the surface. Whereas what is normal reaction? Don't you think it is ulta? It is by the surface on the body. By the surface on the body. That means if you are sitting on a bench right now, your weight is acting on the bench, which is downwards, vertically downwards. And the bench is reacting back on you. The bench is reacting back on you. If I think about this water bottle over here, if I think about this water bottle over here, weight is acting vertically downwards, and therefore normal reaction is acting vertically upwards here, vertically upwards here. But what if my palm is tilted like this, and I am holding the bottle this way? Weight is still acting downwards because the bottle will be coming downwards this way, and the normal reaction is acting perpendicular to the bottle by the surface, means by my palm. Just let me know, have you understood this too? Yes. Very, very, very important, right? Now, suppose the surface is not horizontal like this. Surface is not horizontal like this, but the surface is tilted through some angle, right? That means originally it was like this, right? Originally it was like this, but now it is like this. So it is called inclined surface, or it is simply called inclined. It is called inclined surface, or it is called inclined. That means the body would appear like this to you. The body would appear like this to you. Maybe this is your car. Maybe you are driving, on a hill road. Your car is going up, or maybe your car is coming down. Tell me, students, what is this? What is this point? Is it not center of mass or center of gravity? If you want to talk about where is the entire mass concentrated, then you call this as CF. And if you want to say where is the entire weight is concentrated, then you call it as CG. Later in a chapter you are going to study in rotational motion that CG and CM may be same, may not be same. If you have got absolute uniform bodies, proper shapes, cuboid, cube, exact sphere made up of the same material, then center of mass and center of gravity are same. But suppose I am giving you a sphere, part of it is made up of copper, part of it is made up of aluminium, part of it is made up of wood, part of it is made up of clay, right? Then center of gravity will not be the center of the sphere because the densities are not same. Materials out of which it is made is not the same. Human body is non-uniform distribution of mass because our body is symmetric from here, no doubt about this, right? If you think about this line. But inside, your bones are not equally heavy. This bone, femur bone, this bone, they are not equally heavy. That means mass distribution is not uniform in human body. Remember that. Thereafter, over here, can I say this is inclined through some angle theta? Now, as per our this knowledge, how will weight act? Can I say weight is still acting vertically downwards? Yes or no? That means this is W, which is equal to mg. But how will normal reaction vector weight? Mind you, this is inclined surface, right? So this cannot be normal reaction. Normal reaction has to be perpendicular this way. Normal reaction vector has to be perpendicular this way. Now very, very, very important. Students, if this was the surface, can I say this was normal reaction? Do you agree with me? If the road was like this, then this is normal reaction. But if the road is tilted through some angle theta, now the road is like this, right? Now the road is like this. This is inclined. Correct? Don't you think normal reaction vector should go this way? Normal reaction vector should go this way. That means this is new normal reaction vector. Now, let me call this as n dash. Right? What does this mean? If this road is inclined through an angle theta, don't you think this angle is theta? It is so simple as this. The pen is normal reaction vector and my palm is the surface. If my palm is exactly horizontal, normal reaction vector is exactly vertical. Right? Now if my palm is tilted through 30 degree, Can I say normal reaction vector is tilted through 30 degree? If my palm is inclined through 45 degree, normal reaction vector is also inclined through 45 degree. That means by whatever angle the road is inclined, can I say by the same angle this is inclined? And this is going to help us in understanding resolution of a vector. ये horizontal road था, ये inclined road है, right? I try to draw a little magnified diagram, right? This is the body, this is the body, this is the body, this is center of mass of the body. And as we see, weight is acting vertically downwards. Weight is acting vertically downwards. W is equal to mg. Do you agree with me? Normal reaction is this way. Yes. Normal reaction is this way. Now if I think about extreme left diagram, this one, can I say N is equal to W is equal to mg? Because W is exactly vertically downwards, N is exactly vertically upwards. That means exactly vertically upward force is balancing exactly vertically downwards force. But what about this? W is exactly acting vertically downwards. But normal reaction vector which was acting vertically upwards now is not acting vertically upwards. Now it's not. Because it is acting this way. So in this diagram, do you think I can write N as W? Answer is no. Answer is no. That means I have to go for resolution of a vector. If a force is not balancing other force, then component of that force must be balancing the other force. Right? Either component of first force is balancing the second one, or component of second force is balancing the first one. So what we need to do is, we should think about both of them. Right? I should think about resolving W also, and I should think about resolving N also. So how to do that? For that, take help of this diagram. ये एंगल कितना था? What was this angle, students? थीटा. तो ये एंगल थीटा हुआ कि नहीं? सबसे इंपॉर्टेंट पार्ट ये कि ये थीटा है तो ये थीटा क्यों है? So for this, what is the explanation? By whatever angle the horizontal is inclined, by the same angle normal reaction vector is inclined. Convinced? Now what you should do to go for the resolution of a vector, what you should do, आपका जो भी वेक्टर आपके पास अवेलेबल है, आपके पास दो वेक्टर्स अवेलेबल है, N and W. You should extend the vectors available in reverse direction. Right? So I am extending W in reverse direction. I am also extending N in this direction, opposite direction. So apply common sense. So apply common sense. This is theta. This is theta. So do you agree with me? This is also theta. Yes. That means I can resolve N into its components, and I can resolve mg also into its components. Let us go for first N, resolution of N. So can I say when I resolve N into its components, it is 1 and it is 2. Am I right? When you resolve the vector into components, you should search for a parallelogram. Do you see a parallelogram here? So if this is theta, this is N, can I say adjacent side is N cos theta? And this is N sin theta. Likewise, when I resolve mg, right? This is one vector and this is another vector. I can see another parallelogram over here. I can see another parallelogram over here. This is theta. This is mg. So this should be mg cos theta. And this should be mg sin theta. So I can see two parallelograms here. Parallelogram number 1 is this, and parallelogram number 2 is this. Right? Now I will have to check which parallelogram is working for me right now. This is like car going down or car going up against gravity. I have to see which vector is doing what. So let us first try to visualize N vector. Okay. I have got two components. One is N sin theta, other is N cos theta. Please look at the diagram and tell me what is N cos theta doing. Remember, exactly upward force should be balanced by exactly downward force. Right force should be balanced by left force. Front force should be balanced by reverse force. Northeast should be balanced by southwest. Northwest should be balanced by southeast, and so on. So what is n cos theta doing here? It is balancing mg. But what about n sin theta? N sin theta is unbalanced force. Now if parallelogram number 1 was correct, then n sin theta is this, right? Unbalanced force. That means your body ऐसे जाना चाहिए. And imagine a situation, you are coming down the hill, this is your car, and when you come here, you take off like a plane. Is it not stupid? Is it not stupid? Is it possible? It is not possible. That means this resolution over here was wrong. We just tried it. I have two parallelograms, so I have to think about which parallelogram is correct for me. Yes or no? Parallelogram number 1, as per the situation, is wrong. Understood why? Because n cos theta is balancing mg. Agreed. Mind you, for this article it is wrong. In future, you are going to have concepts like banking of roads, going along a curve, you are driving the car on a circular road. That time you will see this is correct, this is wrong. So mind you, it is situational. Right now, I am saying this body is coming down. I am saying this body is coming down or going up. The body goes up or comes down. So the situation is the body goes up or comes down. That means I am driving the car on ghat or on a hilly area. So my car is either coming down or going up. Don't you think this is not working? Let us try for this now. Concentrate on the green ones. What is the job of mg cos theta? Come on. What is mg cos theta doing? Mg cos theta is balancing normal reaction vector. Job number 1. How about mg sin theta? mg sin theta behaves as unbalanced force. It behaves as unbalanced force, and therefore the body comes down in the direction of unbalanced force according to Newton's first law. Unless and until the body is acted upon by some external unbalanced force. If the body is at rest, it remains at rest, and if the body is moving, it continues to do so in the same direction with same velocity. Yes or no? So over here, out of two parallelograms, which parallelogram is working for us? Second one. What is mg sin theta doing? Mg sin theta is bringing the body down. So actually speaking, when you are driving on ghats, on hilly area, and if you switch off your engine, just control your steering wheel. In fact, save fuel. If you know, okay, you are on a Lonavala Ghat, or maybe you are on a Kasara Ghat, maybe you are on Mahabaleshwar, and you know that आने वाले 3-4 किलोमीटर तक मुझे नीचे ही जाना है, करेक्ट? सो इंजन ऑफ कर दो, ऑन करके खाली गाड़ी न्यूट्रल में रखो, but simply that your fuel is saved. That means actually speaking, your car is switched off. Don't you think gravity is helping you to go down? Only thing is when the curves come, you have to move the steering wheel to control the car, right? But when you're going up, don't you think your engine will have to do more work? Reason? You are going against gravity. So when you are going against gravity, that means you will have to apply greater amount of force to go up. Is that very, very clear? This concept is going to help us to understand question number 1 of your assignment number 5. Okay? And this is synopsis point number 38 going on right now. Have you understood this diagram? Yes. Extremely well. Always remember, first you draw the forces. Then you see whether they are equal and opposite or not. If they are not equal and opposite, search for theta. Because if you don't have theta, you can't write the components. If I have vector A, I should have theta also, because then only I can write A cos theta and A sin theta. So first I should search for theta. Then I will draw the possible parallelograms. And then I will see which parallelogram is working for me as per the situation. So right now, which parallelogram is working for me? The black one or the green one? The green one. Yes or no? एकदम अच्छे से समझा. Now, because we have just done this article, let us take up a problem on this. So we understand how do they apply this. But before that, what can you say about weight of the body? Weight of the body is the force with which the body is accelerated towards the center of the planet, center of the earth, right? And it always acts, don't say downwards, it would be incomplete statement, say vertically downwards. And what is the meaning of normal reaction force? It is the force exerted by the surface on the body, definitely in perpendicular direction, right? So that is this diagram. This diagram is to understand how to decide theta. I'm sure you are comfortable with that. And then this diagram is to understand the final vector diagram. Final vector diagram. Right from the beginning of the chapter, I have been telling you again and again and again, if you know how to draw the vector diagram, if you know how to draw the vectors, right, then 90% of your job is done. Then you just have to think about what is asked and how to do it. Understood, everybody? Now what you should do is, first, please move on to synopsis point number 38, everyone. Please move on to synopsis point number 38. If you can help me with page number 42. Everybody, page number 42. Point number 38 को बेटा 20 स्टार मार्क करो. Without fail, जब ये मैं बोर्ड पर भेजूं, without fail, please इसका प्रिंट आउट निकाल लेना. Right? Because this is the best board work I am going to send you. Right? When you were busy writing the DCT, I was doing my work so that when we start, your time is not wasted. Okay? So when I send this to you, without fail, take the print out of this. Now what you should do in point number 38, you should check the middle diagram first. Sequence लिख के रखो बेटा. Middle diagram के ऊपर number 1 लिख के रखो. Left diagram के ऊपर number 2 लिख के रखो. और right diagram के ऊपर number 3 लिख के रखो. Middle diagram explains you how the normal reaction vector x and how wx when the surface is horizontal. Left diagram explains you what happens when the surface is inclined, right? Left diagram is explaining you how the surface is inclined what to do. And left diagram also explains you how to decide theta. Very important is beta ye theta क्यों है, right? And then we are applying our knowledge of first diagram and second diagram to understand the final diagram. Final diagram का literature पढ़ो. Final diagram का कौन सा वेक्टर क्या कर रहा है, उधर लिखा होगा mg cos theta is balancing the normal reaction vector and mg sin theta is unbalanced force. That means it is helping the body to come down. By chance if the body is going up, ध्यान से सुनो बेटा, अगर ये body ऊपर की तरफ जा रहा है, इसका मतलब the body will have to do additional work to overcome the frictional force which is existing between the body and the surface. When you want to go up, no, you will have to put in more efforts. Suppose there is a mountain cliff 3 kilometers. One person is going from down to the mountain cliff top, and the other person is coming from up to down. दोनों ने 3 किलोमीटर का distance cover किया है. Who will get tired more? The one who is going up, because you are going against the gravity, right? When you come down, that means you are going in the direction of gravity, so it is helping you. Is that very clear? अच्छे से समझा? तो आप लोग point number 38 एकदम ध्यान से पढ़ो, बहुत easy है, बहुत easy. Point number 38. Point number 38. Okay? Point number 38 is very easy.
If we were going upwards, then we would still use mg cos theta.
Yes. That all depends on theta कहाँ पे दिया हुआ है, और उसमें फिर frictional force का भी additional term आएगा. So when you start with the chapter friction and viscosity, you are going to come across this as well as some additional force. Is that clear? Point number 38 समझा बेटा? अभी आप point number 38 में लिख के रखो. Solve. Assignment number 5. Solve assignment number 5. Questions 1 to 29 and 33. Point number 38 में आप लिख के रखो. Solve. Assignment number 5 means HOTS. Question numbers 1 to 29 and 33. As you know, you don't have to copy anything from the board. Reason, I have already given you complete solution. Your focus should be on the board. But when you go home, don't look at the HOTS which I am teaching today. मतलब ये 4 क्वेश्चन नहीं देखना है, बाकी सब रिवाइज करना है. संडे ये पूरा बोर्ड वर्क आपका होमवर्क. संडे, because you have to show me this homework on Tuesday. Is that clear? And do all these questions again and again, because next Sunday is again going to be physics wala Sunday. So I'll increase the difficulty level, right? And coming week mein I will try to find out some external material also, some PDF file from external book, so that you can try questions from external books also. Because see, the new books are coming in the market, but I am waiting for the latest most book, right, which is based on the latest most syllabus, which normally comes in mid of July. and we don't want to wait till then. So at least I will send you one chapter का PDF file so that you can try from external books. Is that clear? Are you all on assignment number 5? Are you all on assignment number 5? Question number 1. Question number 1. एकदम ध्यान से देखो बेटा. A body of mass 10 kg is placed on a smooth inclined plane making an angle of 30 degree with the surface. Don't you think the diagram is exactly this? Right? This is the horizontal surface. This is the incline. This is the horizontal surface. This is the incline. And the incline is making an angle of 30 degree with the surface. So, in question number 1, assignment number 5, what is given, students? Mass of the body is 10 kilogram. Right? They have given you gravity value also, 9.8 meter per second square. Now, mind you, normally it happens that in multiple choice questions, they most of the times give you G as 10 meters per second square. That means they give you that round figure. If they give you 10, take 10. If they don't give you anything, it is your choice. You can take 9.8 also, you can take 10 also. Right? Otherwise, whatever they give, you take that. What is the angle given, students? 30 degree. Now see what is the question. The question is, find out the component of the force of gravity trying to move the body down the inclined plane. Look at the diagram and tell me which force is bringing it down. Right? So the force which is responsible for the body to come down from this diagram is mg sin theta. तो बेटा एकदम सिंपल क्वेश्चन है कि नहीं? That means it is 10 into 9.8 into sine of 30. That means it is 98 into half, and therefore your answer is 49 न्यूटन. अब एकदम ध्यान से सुनो, ये मेरा आंसर हुआ ऑफिशियल यूनिट में. ये मेरा आंसर हुआ ऑफिशियल यूनिट में, मतलब न्यूटन. Sometimes what they do, they give all the options in kilogram weight only. मतलब ये मैं न्यूटन में दूंगा ही नहीं. फॉर एग्जाम्पल, जस्ट टेम्परेरीली हैव ए लुक एट प्रॉब्लम नंबर 2. जस्ट टेम्परेरीली हैव ए लुक एट प्रॉब्लम नंबर 2. ऑफ कोर्स वो ये कॉन्सेप्ट पे नहीं है, वो टेंशन वाले कॉन्सेप्ट पे है, राइट? सो जस्ट हैव ए लुक एट दैट पर्टिकुलर. हैव यू सीन ऑल द ऑप्शंस इन केजी वेट? तो वहां पे बेटा जी सब्स्टिट्यूट ही नहीं करने का. तो फिर मेरा आंसर क्या आएगा? इट विल बी 10 into sin 30. दैट मींस इट विल बी 10 into half. दैट मींस इट विल बी 5. लेकिन अभी न्यूटन नहीं लिखने का. आंसर लिखने का केजी वेट या तो फिर केजी फोर्स, और ये हो जाता है बेटा ग्रेविटेशनल यूनिट. ये हो जाता है ग्रेविटेशनल यूनिट. सो यू हैव टू लुक एट द ऑप्शंस एंड डिसाइड योर स्ट्रेटेजी whether you should substitute G or you should not substitute G. Sometimes students say कि सर पहले प्रॉब्लम में G दिया है इसलिए यूज करना है, दूसरे प्रॉब्लम में G नहीं दिया है इसलिए यूज नहीं करना. ऐसा कोई लॉजिक नहीं होता है बेटा. मैं दोनों में G दे दूंगा, लेकिन एक में ऑप्शन दूंगा न्यूटन में और एक में ऑप्शन दूंगा केजी वेट में. तो मैंने G दिया है तो भी आपको यूज नहीं करना है. रीजन, I did not give you options in Newton. Simple. If I ask you your weight, what do you say? Sir, I am 60 kilogram. Did you say, sir, I am 60 into 9.8 Newton? Because this is the normal way we talk in day-to-day life, right? Even if you know that 60 kilogram weight is scientifically wrong answer, but everybody around us is not a science student, so we talk in terms of kg weight, what everybody understands. Are you getting my point? So remember, even if G is given, but if I give you options in kg weight, then you should not use that G. Is it very, very clear? Question number 1 के बाजू में लिख के रखो. Since options are in Newton, G should be substituted. Since options are in Newton, G should be substituted. Second question में लिखो, जो अभी तक हम लोगों ने किया नहीं है. Second question में लिखो, since options are in kg weight. Since options are in kg weight, G should not be substituted. Since options are in kilogram weight, G should not be substituted. So when you don't substitute G, you are trying to find out your answer in gravitational units. And when you are substituting G, that means you are trying to find out your answer in official units. Shall we continue? Please let me know frankly, students. Have you understood this part? अब ये part मैं extra सिखा रहा हूँ because it is going to help you in the chapter oscillation. It is going to help you in the chapter rotational motion. It is going to help you in the chapter circular motion. It is going to help you in the chapter Newton's laws of motion. Wherever the word pendulum comes, pendulum, this is going to help you. Okay. Now listen to this very, very carefully. If I am giving you a rigid surface, okay, which is the ceiling of this classroom, okay, I am giving you a string, or otherwise I am giving you a rope, or otherwise I am giving you a wire, whatever. That means, mind you, this is a hanging body, okay, and this is called bob of the pendulum. This is called bob of the pendulum. Bob of the pendulum is usually a heavy metal sphere, right? This is the center of mass. So what forces are acting over here? Come on, this force you already know. What is this force? W or mg, which is always acting vertically downwards. But now when you talk about the reverse force, the way you talked about the reverse force here, right? The reverse force is going to be here, and this force should not be called normal reaction. This force should not be called normal reaction. This force is called tension force. So remember, if you are talking about a body lying on the surface, if you are talking about a body lying on the surface, then you should always talk about normal reaction force. Okay, never talk about tension force. But if you are talking about a body hanging with the help of, if you are talking about a hanging body with the help of a string or a rope or a wire, whatever, you should never use the word normal reaction. Now you should use the word tension. So it is something like this. If it is something like this, I am taking this body. I am taking this body. I am taking this body, and I am putting this body on my palm. Right? So this is a body lying. So weight of the umbrella is acting downwards, and therefore normal reaction is acting upwards. Now imagine this full thing is not an umbrella. This is a string, or maybe the body is only here, and I am holding it from here. Right? I am not holding umbrella. I am holding the string, but still I feel the weight of the umbrella or no? Right? Who makes me feel that? Who makes me feel that the umbrella is heavy? The tension. Mind you, feeling tension and being tensed are two different things. Feeling tension and being tensed are two different things. If I can show it to you, let me try. If I can show it to you. Come on. I will try to show this to you. If I am tying a rope around his neck, if I am tying a rope around his neck, right, and he is penalized by, penalty of that, he is maybe a terrorist, and the court of law says that he has to be hanged till death, right? So when he is to be hanged till death, right, he is tensed because marne wala hai. But because I am holding it, I feel tension. Why I feel tension? His weight is acting downwards. I am holding it. Right? That means I feel something heavy. Who is that heaviness? His weight. So I am holding the string or I am holding the rope. That means I feel tension. So when I feel tension, that is physics. Thank you. And when he is tensed, that is English. He is tensed. English. I feel tension, physics. लॉजिक समझा बेटा? श्योर? तो इधर टेंशन वर्ड यूज करने का ही नहीं, और इधर नॉर्मल रिएक्शन वर्ड यूज करने का ही नहीं. इधर नॉर्मल रिएक्शन, इधर टेंशन. हैंगिंग बॉडी, लाइंग बॉडी. लॉजिक समझा? Now, if this is the situation, then the way I said N is equal to W is equal to mg. Can I say T is equal to W? Yes or no? Because tension is T and W is mg. So what will I say? T is balanced by W is balanced by mg. But what if I disturb this? What if I push this bob? Can we say it will perform oscillatory motion? इसका मतलब ये हुआ कि पहले ये इधर था, पहले ये इधर था इसलिए मैं डॉटेड लाइन बता रहा हूं. पहले ये इधर था, ओके था इसलिए मैं डॉटेड लाइन बता रहा हूं, लेकिन जब मैंने इसको पुश किया, इज इट गोइंग टू द राइट और लेफ्ट? राइट, मतलब ये ऐसे गया, मतलब अभी ये इधर है, अभी ये इधर है. That means this is the string now. This is the string. So how will I talk about the vectors? Like I always do. Come on students, what is this force? W is equal to mg. Very good. And what is this force? Tension. Yes or no? Is it making some angle theta at the top? हाँ, क्या सिखाया था मैंने? क्या सिखाया था? सबसे पहले थीटा लेके आने का. तो व्हाट यू शुड डू, व्हाटएवर फोर्सेस आर अवेलेबल टू यू, मेरे पास mg अवेलेबल है, रिवर्स डायरेक्शन में मैं लाइन बनाऊंगा. मेरे पास टेंशन अवेलेबल है, रिवर्स डायरेक्शन में मैं लाइन बनाऊंगा. डू यू एग्री विथ मी? If this angle is theta, that means this angle is theta, and that means this angle is theta. Right? That means I can resolve tension also, and I can resolve mg also. Right? So first I will resolve tension. ये कौन हो गया बेटा? ये कौन हो गया? t cos थीटा बराबर, और ये कौन हो गया? t sin थीटा. तो ये मेरे पास दो कंपोनेंट्स है. मेरे पास एक पैरेललोग्राम बना. लेट मी लेबल दिस एज पैरेललोग्राम नंबर 1. पैरेललोग्राम नंबर 2. This is mg cos theta. Do you agree with me, students? And this is mg sin theta. Do you agree with me? ये मेरे पास दूसरा पैरेललोग्राम हो गया. अभी कॉमन सेंस अप्लाई करो, कौन सा वाला सही है ये सिचुएशन के हिसाब से, पहला कि दूसरा. माइंड यू, बॉब ऐसे आ रहा है, सेकंड वन, क्योंकि अगर फर्स्ट वन करेक्ट होता ना तो सिचुएशन ऐसे होता. ये ऐसे गया, फिर ऐसे आया. सोचो इसमें फर्स्ट वाला सिचुएशन करेक्ट होता तो कितना फनी सीन होता है ना. योर कार इज कमिंग डाउन and then you are taking off. आपको देखिए आजू बाजू वालों का एक्सीडेंट हो जाए, because yours is a flying car. Are you getting my point? Imagine you are on a highway and all of a sudden you take off. Right? That is wrong. That is wrong. So यहाँ पे first diagram wrong था. Likewise यहाँ पे ये diagram wrong है. Again situational है. मैं ये नहीं बोल रहा हूँ कि ये diagram हमेशा wrong है. आगे जाके conical pendulum आएगा. Conical. तो उसमें ये diagram सही है, ये wrong है. There are two types. One is simple pendulum. Other is conical pendulum. Simple pendulum means what? The body goes this way. And conical pendulum means what? The body goes this way. Is it giving you appearance of a cone? So this is simple pendulum. See, there are totally 4 situations. Horizontal circular motion. अभी ध्यान से देखो. Horizontal circular motion, and I slow down. So when I slow down, does it look like a cone? Now vertical circular motion, and I slow down. So later when I slow down, when I don't apply force, will it go this way? So when horizontal circular motion is slowed down, ultimately the circle will become of smaller radius, and it is called conical pendulum, right? Whereas vertical circle, when it slows down, it is simple pendulum. You see both this kind of rides in amusement parks. You go to SL World, you go to Imagica, okay, and you see situations somewhat like this. If something happens to the rope or the string, what will happen? The particle will fly off along the tangent. So imagine you are in the ride Rainbow, and all of a sudden something happens to that beam, right? So you are in a ride Rainbow, the beam breaks, and therefore you fly off along the tangent. So you purchase the ticket of SL World, but you are found in Water Kingdom. Or you purchase the ticket of SL World, and maybe you are found in Gorai Creek. Right? You are in a roller coaster, and all of a sudden the beam breaks. Are you getting my point? Absolutely serious accident, right? And this kind of accidents have happened in the world. एक एक्सीडेंट इमेजिका में भी हुआ था. हाँ, रोलर कोस्टर का राइड चल रहा था, कुछ तो स्क्रू नट बोल्ट ढीला था, और जब राइड नीचे आया, there was a derailment. Some people got injured also. It happened even in one of the Disney parks in the world. I think it was Orlando only, right? So if this kind of accident happens, that means the engineers have to be super duper alert. Before these rides are open to public, they will have to check all this. That is called quality control, right? And unless and until they are very sure, they will not open these rides for public. One of the movies was like this. हॉलीवुड मूवीज, फाइनल डेस्टिनेशन, आई थिंक देयर आर 4-5 पार्ट्स. तो उसमें क्या होता है ना कि वन ऑफ द एक्टर्स has that far sight कि they can see little in future. So one of the girls, she can predict the future. So you know she's something like this कि after 4 hours or maybe next day we are going to go to some amusement park, we are going to be sitting in a roller coaster, there will be some loosening of the nut bolts and our ride is going to collapse, right? So she says कि let us not go for this because she saw this a day before. So her friends are saying what nonsense, ऐसा कुछ होता है क्या, how can you see future, nonsense, it must be a dream or it must be a nightmare, don't worry. And second is seriously that accident happens. So that is the best example of what happens when proper force is not applied. यहाँ तक समझा? So यहाँ पे कौन सा particular argument right है, first parallelogram कि second parallelogram? So यहाँ पे कौन क्या करता है, सोच के बोलो. Mind you आपको green पे ध्यान देना है. So what is mg cos theta doing बेटा? What is mg cos theta doing? It is balancing tension. And what is mg sin theta doing? Mg sin theta is the unbalanced force helping the body to come back. And don't you think this mg sin theta is always acting towards the original position? अगर ये मैंने डायग्राम राइट साइड पे बनाया है तो mg sin theta लेफ्ट साइड पे दिख रहा है. सोचो ये पेंडुलम अभी इधर आएगा तो don't you think mg sin theta इधर दिखेगा? So mg sin theta, mg sin theta. So it goes this way. If it is going this way, mg sin theta is this way. And if it is going this way, mg sin theta is this way. So mg sin theta is always helping the body to come back to original. So the way here mg sin theta was helping the body to come down, here mg sin theta is helping the body to come back to original. Don't use the word tension, don't use the word normal reaction. If you come across a problem where they have used the word string or rope or wire, if it is a hanging body, you should always use the word tension, never use the word normal reaction. Is it very clear to you? अब बेटा ये आपके सिनॉप्सिस में नहीं है क्योंकि ये दूसरे चैप्टर को बिलोंग करता है. मैं स्ट्रांगली सजेस्ट करूंगा आप इतना पार्ट अपने बुक में कॉपी करोगे और एक्चुअली तो कुछ करना ही नहीं है. फ्रेंकली स्पीकिंग, जब आप घर पे जाओ, जब भी आपको टाइम मिले, इसका तुरंत प्रिंट आउट निकालो और ये प्रिंट आउट बुक में ही अटैच कर दो. रीजन आई एम टॉकिंग अबाउट सम अदर फोर्सेस ऑल्सो. प्लीज लेट मी नो. Are you comfortable with this entire thing? Are you comfortable with this entire thing? Yes or no? Let us solve problems on this so that we come to know how do they apply this. Okay? Are we on problem number 2 now? Are we on problem number 2? Shall I start? A ball of mass 3 kg is suspended by a light string and is pulled by a horizontal force so that the string makes angle 60 degree with vertical. मतलब क्या हुआ बेटा, समझा? मतलब ये हुआ कि ये बॉडी पहले ऐसे था, ये पहले ऐसे था. अब या तो मैंने इसको पुश किया और या तो मैंने इसको पुल किया. So is it a horizontal force because of which I will see something like this? Okay. So the moral of the story is this. The moral of the story is this. The moral of the story is this. Suppose this is the simple pendulum. This is the simple pendulum and I am giving horizontal force to this. That means the pendulum has gone here. Yes or no? It is making some angle theta. And that theta I think they have given you. Okay. Now one by one, students. ये कौन सा force हो गया बेटा? Horizontal force. और ये कौन सा force हो गया? Vertical force. This is horizontal force. This is vertical force. Correct? That means the resultant force is none of them. The resultant force is this red one. Think on this. ऐसा प्रॉब्लम हम लोगों ने लास्ट टाइम किया था कि नहीं? वो थीटा इज tan इनवर्स ऑफ a by g वाला. सेम असाइनमेंट, असाइनमेंट 5 क्वेश्चन 4 चेक किया था लास्ट टाइम और अपना आंसर आया था थीटा इज tan इनवर्स ऑफ a by g. वहां पे एक्सीलरेशन का प्रॉब्लम था, यहाँ पे फोर्स का प्रॉब्लम है. तो आपको मल्टीप्लाई एंड डिवाइड बाय m करना है. यस और नो? अभी सोचो ये थीटा है तो ये थीटा हुआ कि नहीं? सबसे मेन थीटा का लोकेशन है, सबसे मेन थीटा का लोकेशन है. एवरीबडी, इफ दिस इज थीटा और नो? If this is theta, this is theta or no? So can I say tan of theta? Tan of theta is opposite force upon adjacent force. थीटा के सामने वाला साइड कौन सा है? हॉरिजॉन्टल. और थीटा के बाजू वाला साइड कौन सा है? वर्टिकल. थीटा के सामने वाला हॉरिजॉन्टल, थीटा के बाजू वाला वर्टिकल. सो tan of theta is horizontal force upon vertical force. Apply common sense. Vertical force by default is mg, no? Vertical force is by default weight of the body, right? What is tan theta as per the question? tan of 60. Horizontal force पूछा है बेटा, और vertical force क्या लूंगा मैं? Vertical force is the weight of the body. ध्यान से देखो, 3 kg weight लिख रहा हूं मैं, चलेगा? न्यूटन में कन्वर्ट ही नहीं किया. क्यों नहीं किया? सारे ऑप्शंस kg weight में है. तो मेरा आंसर आ गया, this is √3, this is horizontal force और this is 3. So what is my answer? 3√3 kilogram weight. My answer is 3√3 kilogram weight. Understood? एकदम श्योर. रिपीटेशन रिक्वायर्ड. मैं वापस आपको फर्स्ट प्रॉब्लम पे लेके चलता हूँ. फर्स्ट प्रॉब्लम में अपना आंसर आया था 49 न्यूटन. क्यों? क्योंकि उन्होंने बोला था कि व्हाट फोर्स इज ब्रिंगिंग इट डाउन. व्हाट फोर्स इज ब्रिंगिंग इट डाउन, अपना आंसर था ये. वही फर्स्ट प्रॉब्लम में कभी कभी वो लोग बोलते हैं नॉर्मल रिएक्शन ढूंढो, नॉर्मल रिएक्शन ढूंढो. तो कॉमन सेंस ना बेटा, नॉर्मल रिएक्शन इज mg cos थीटा. तो फर्स्ट प्रॉब्लम में अगर नॉर्मल रिएक्शन पूछा तो ओरली सॉल्व करते हैं. ये कितना था फर्स्ट प्रॉब्लम में? 10. ये था 9.8, तो 98 हो गया, और ये हो जाएगा √3/2. तो 98/2 is 49. 49√3 will be your answer. 49√3. So I want you to make a little addition in problem number 1. In problem number 1, you add option E. Option E. And you write it as 49√3. You write it as 49√3. उसके बाजू में लिखो if normal reaction was asked. Mind you, if normal reaction was asked in problem number 1, your answer was 49√3. Please let me know, students, have you understood first question and the second question? Have you understood first question and the second question? Sure? Okay. अभी मैं पहले आपको ये कॉन्सेप्ट सिखा देता हूँ, उसके बाद में I will take you on to problem number 29 and 33. Both those problems are based on this, and actually speaking, they are the problems taken from your 12th standard syllabus. Name of the chapter is oscillation. Those two problems are taken from 12th standard, and in fact problem number 33 had come in IIT, and it had come in JEE Advanced, saying that which of the following statements are correct, और उसमें 3 आंसर्स करेक्ट है. तो मैंने उसको कन्वर्ट कर दिया CET में और JEE मेंस में. उसमें मैंने वो जो विच आंसर करेक्ट के बदले बोल दिया विच आंसर इज रॉन्ग. 3 करेक्ट है, 1 रॉन्ग है. तो ऑब्वियसली योर नीट स्टाइल, CET स्टाइल, JEE मेंस स्टाइल इज व्हाट, 1 आंसर इज करेक्ट. सो आई विल आल्सो टेल यू कि ओरिजिनल क्वेश्चन क्या था, राइट? बट बिफोर टेकिंग ऑन टू दैट, द न्यू कॉन्सेप्ट, द कॉन्सेप्ट ऑफ buoyant force, Archimedes principle. When you are swimming, do you feel little loss in weight? Mind you, it is just a feeling, it is not reality. You just feel when you are swimming that you have lost a little bit. Now, the swimming pool looks like this. Yes or no? The swimming pool is like this. This is 2 feet deep water, 3 feet deep, 4 feet deep, 5 feet deep, 6 feet deep, 7 feet deep, 8 feet deep. और यहाँ पे लिखा है diving not allowed. Because sometimes out of excitement, if you are beginner particularly, if you don't know how to dive, you may dive this way, right? This portion strikes with the ground and you may lose your senses. You may faint temporarily, and after that you may die also out of suffocation, right? So when you dive, it should be enough deep swimming pool, around at least 15 feet deep, and that too you should dive from the ground only. If you go to the first floor and dive, if you go to the second floor and dive, you will further go down, you can again hit. But when you're jumping from first floor or the second floor, actually speaking, you know swimming well, and then only you are doing this, or otherwise you are doing this under the supervision of the swimming coach, right? Now what is the meaning of upthrust, right? When you are jumping into the swimming pool, you are on a springboard and then you jump into the swimming pool. First you will go in water and then you come out, you come up. Who sends you up? The buoyant force, Archimedes principle, that is called up thrust. Up means up, thrust means force. Up means up, thrust means force. You repeat the experiment, jump into the swimming pool without water in it. Will you come up? Probably you will go up. Yes or no? So who was responsible? Liquid force. Now check, what is it? You are in a swimming pool and you are here. This is you. Maybe you are a 5 feet tall guy, right? Then you are here. You are gradually going deeper and deeper and deeper. Okay? You are going deeper and deeper and deeper. Don't you think here you are displacing some amount of volume in upward direction? I am in a 2 feet deep swimming pool. That means this portion of the body is underwater. So I will displace that much water up. Now I go little deep, little more deep, little more deep, little more deep. I am completely in water. This is the highest volume of water I can displace up. Whatever is my volume. Yes or no? So why do you feel loss in weight? Apparent weight is the weight felt by you. Is real weight, which is your actual weight, minus the upthrust. Right? Now what is upthrust? Upthrust is buoyant force. Right? And force is given by mass into gravity. Mass is given by density into volume. So it is density into volume into gravity. Density cannot change. Gravity cannot change. But volume of water displaced by you was changing. Where did you displace maximum water? When you were here or here. When did you displace minimum? Here. So whatever volume you displace, accordingly that much loss you will feel. That much loss you will feel. Suppose I am 100 kilogram. Now I displace 10% of the volume. I will feel 10% of loss accordingly. Means suppose I am 95 kilogram. I may feel 94.9. Means I feel that I have lost 100 gram. Right? Later 94.8. I lost 200 gram. Highest is suppose 94.5. Means I feel that I lost half a kg without any exercise or without any diet program. Absolutely no. The moment I am out of water, I am back to reality world. I will feel what I am. Is that clear? So apparent weight means the weight felt by you. It is not reality. It is situational. Whether you are swimming or you are in a lift and the lift is going up or down, we are going to do that also. So very important. What is apparent weight? Weight felt by you. What is that? Real weight minus the upthrust. Why minus? Because you feel loss. Right? So if you are 95 kilogram, you are feeling 95 minus some little weight. That is called because of upthrust. So what is the formula of upthrust understood? Upthrust is mg. So it is rho vg. Mass is density into volume. And what is the meaning of volume here? It is that volume which you are displacing. And that depends on you how inside you are, how much inside you are. Ye part samjha? Another feeling of losing weight or gaining weight is inside the lift. You can literally try this experiment. Very easy experiment. What you simply need is weighing machine, portable weighing machine. Take a portable weighing machine, go inside the lift, keep the weighing machine on the floor, be ready with pencil and paper and just record your weights. First you record your weight when the lift is at rest. So when the lift is at rest, you are exerting your weight downwards. That means this is center of gravity of yours and this is weight exerted by you. अब बेटा ऊपर की साइड पे कौन आएगा? नॉर्मल रिएक्शन आएगा कि टेंशन? बिकॉज आप एक फ्लोर पे खड़े हो, राइट? अब लिफ्ट ऊपर भी नहीं जा रहा है, नीचे भी नहीं आ रहा है. इसका मतलब N is mg. You feel what you are. You feel what you are. But the lift moves up with acceleration. The lift moves up with acceleration. Suppose you were on the ground floor of this building and it is a 60-story building, because you will feel this very nicely if it is a multi-story building, right? Initially the lift goes very fast. Initially that means it is speeded up. अभी ध्यान से सुनो बेटा, ये कौन है? mg. ये कौन है? नॉर्मल रिएक्शन. लेकिन अभी आप रेस्ट पे नहीं हो ना, अभी आपका लिफ्ट ऊपर की तरफ जा रहा है. तो व्हाट इज द नेट फोर्स स्टूडेंट्स? ऊपर की तरफ. एंड व्हाट इज दैट? ma. बराबर? मतलब ये बाद में आता है, जब लिफ्ट मूव होना शुरू होता है. उसके पहले ये फोर्स था ही नहीं, राइट? तो ये फोर्स बाद में आया. अभी सोच के बताओ, ये दोनों फोर्सेस को आप ऐड करोगे कि सबट्रैक्ट करोगे? सोच के बताना प्लीज. ये दोनों फोर्स को सबट्रैक्ट करोगे. वेरी गुड, बिकॉज दे आर ऑपोजिट. अभी सबट्रैक्शन में it should be either n minus mg or mg minus n. Both cannot be correct. Again सोच के बताना, n minus mg करेक्ट है कि mg minus n करेक्ट? आराम से देखो बेटा, नेट फोर्स कौन सी तरफ एक्ट कर रहा है? ये नेट फोर्स है आपका, ये नेट फोर्स है. मतलब लिफ्ट किधर जा रहा है? ऊपर. मतलब ऊपर वाला बंदा पावरफुल होना चाहिए ना. लेट अस चेक दिस. come here please. ये body है. You try to pull it down, I try to take it up. Right? Pull it down. That means we are applying forces. मैं इसको ऊपर की तरफ खींचने की ट्राई कर रहा हूँ, ये इसको नीचे की तरफ खींचे. The body is going down. That means he is powerful than me. So you should take downward minus upward. लेकिन अभी क्या हो रहा है? Upward minus downward. तो thank you. कौन सा फोर्स पावरफुल है ये डायग्राम में? ऊपर वाला. So what you should write? N minus mg is giving me ma. तो मुझे जो फील हुआ वो फोर्स कौन सा है? N. Is it not m times g plus m times a? बोलो बोलो, समझा कि नहीं? तो जब लिफ्ट ऊपर जाता है मेरा वेइंग मशीन थोड़ा ज्यादा रीड करेगा. अभी वो कितना ज्यादा रीड करेगा वो डिपेंड करता है कि लिफ्ट कितना फास्ट ऊपर जा रहा है. अपना बिल्डिंग 4 स्टोरी बिल्डिंग है, अपने बिल्डिंग में भी लिफ्ट है. ये लिफ्ट का स्पीड इतना ज्यादा हो ही नहीं सकता है. अरे 4 मंजिले का बिल्डिंग है यार. बट इफ यू गो टू बुर्ज खलीफा 160 स्टोरी, उसका लिफ्ट इतना स्लो हो ही नहीं सकता है. अरे सोचोगे कब आएगा यार? आई एम ऑन 4th फ्लोर, व्हेन विल आई रीच 124th फ्लोर? राइट? वहां पे ना 124th फ्लोर पे व्यूइंग गैलरी है. राइट? एंड यू हैव टू पे सम दिरहम्स फॉर दैट, अराउंड 100 दिरहम्स, व्हिच इज अबाउट 2500 रुपीस. राइट? उसकी लिफ्ट का इंडिकेटर आप देखोगे ना तो इट मेक्स यू रीच ऑन 124th फ्लोर, आई थिंक इफ आई एम नॉट रॉन्ग, इन सम 57-58 seconds. You are on 124th floor, mind you. Right? In 56-57 seconds. That means this is a super fast lift. Right? और लिफ्ट क्लोज होता है, मतलब आप बाहर को जो तो आप देख भी नहीं सकते, उतना फास्ट जाता है. अरे बाप रे, मैं इतना स्पीड में जा रहा हूँ. Is that clear? So that time you will feel gain. Why gain? The lift is accelerating up. G का वैल्यू तो फिक्स है 9.8. अभी ये एक्सेलरेशन का वैल्यू सपोज 0.1, then 0.2, then 0.3, then 0.4. Can I say my answer will gradually keep increasing? एक पर्टिकुलर फ्लोर पे आके लिफ्ट यूनिफॉर्म वेलोसिटी से जाएगा. सो रिमेंबर, इफ द लिफ्ट इज गोइंग विद यूनिफॉर्म वेलोसिटी, कैन आई से एक्सेलरेशन इज 0? सो इफ द लिफ्ट इज गोइंग अप with uniform velocity or coming down with uniform velocity or at rest, I feel what I am. My real weight is my apparent weight. But here n का मतलब apparent weight. इधर मुझे ज्यादा फील होगा. If I am 95, I feel I am 95.2. I feel I gained 200 grams. If I am 95, I may feel 95.05. That depends because the lift was slow. So common sense apply करो. अभी लिफ्ट नीचे आ रहा है, मतलब ये डायग्राम का जो F नेट था वो नीचे की तरफ है. राइट? ये कौन है? mg. ये कौन है? नॉर्मल रिएक्शन. सोच के बोलो, n minus mg की mg minus n. This time it is mg minus n. So when I write mg minus n is ma, what is important for me is n, because n makes me feel my existence. Normal reaction makes me feel my existence. खाली मेरे वेट से कुछ नहीं होता है. हाँ, मैं हार्ड सरफेस पे खड़ा हूं तो mg डाउन n अप, लेकिन मैं सी फेस पे वॉक कर रहा हूं. That means I am walking on sand. Sand is a loose surface. My legs go little inside. That means I am heavier than the normal reaction. That's why I go little inside. If you are walking on a muddy road in this particular climate, sand, muddy road, clay वाला road है और गीला हो गया मिट्टी, तो आपका पाँव घुसता है ना उसके अंदर. That means mg is greater than n. But what if you are walking on some rubber membrane? What if you are walking on jumping joker? What if you are on a trampoline? Yes or no? That time normal reaction is greater than your weight. So what you feel is actually speaking normal reaction. सोचो ये surface होता ही नहीं, मतलब I don't have any surface on which I can exert my force. Who will exert reaction on me? And if reaction is not on me, how will I feel? I had weight. Am I right? Very simple experiment. Take a weighing machine, tie it with your legs, and go on a mountain cliff and stand there. Right? Means go on a mountain cliff, stand there, stand on a weighing machine, tie your legs with that. And your focus should be only on the weighing machine. Don't look here and there. Right? You will read what you are. Now jump with the weighing machine. Because the weighing machine is tied with your legs. Your focus should be only on the weighing machine. It will read 0. Reason? You are trying to stand on someone and that someone only is not there. Why? Because that someone is going down with 9.8. So you are saying, wait, I am coming. Right? That weighing machine, get lost, I am going down. Same thing happens here. Coming down और falling down में फर्क है. इधर क्या होता है? Somebody cuts the rope of the lift. Somebody cuts the rope of the lift. Or the rope of the lift is accidentally cut. Down to down ही है ना? मतलब आप इक्वेशन तो यही लिखोगे. How will you write the equation? mg minus n is ma, but a is g, no now, because it is falling down. That means mg minus n is mg. So n is m times g minus g, and therefore you feel weightless. So to feel weightlessness, you do not need to be an astronaut. You may be a layman. You need not be a science student also. You may be a layman. You may be illiterate also. Right? Go in the lift, stand on the weighing machine. Somebody cuts the rope of the lift. You know at least how to read the weighing machine, even if you are illiterate. Yes or no? You will read 0. Weighing machine खराब नहीं हुआ है. Lift खराब हुआ है. Are you getting my point? आपने बिल्कुल weight lose नहीं किया है. आप जितने थे उतने ही हो. फिर भी you feel weightless. Mind you, when you go on moon, your weight changes, not your mass. Not your mass. आप इतने इधर से जितने गए उतने उधर भी हो. राइट लेकिन वहाँ पे ग्रेविटी 1/6 है इसलिए आपको वेट 1/6 फील होता है. आपका मास 1/6 नहीं होता है. अदरवाइज हनी आई श्रम द किड्स. राइट व्हेन आई गो ऑन मून आई कीप रिड्यूसिंग. So ultimately what will happen over here when you go down you disappear. Yes.
So if the left is cut and if it's going down, then initially we were at inertia of rest. But when it's going down, we will get up a little and then we will come down.
Perfect.
It won't actually be 0, no.
Absolutely no. You will feel only when acceleration is there. When you are not in agreement with the system. Very simple. You are in a bus. Bus is at rest. You are at rest. Nothing happens to you. But when the bus starts in forward direction, only for that moment you are going in backward direction. Right? After few seconds, whatever is the speed of the bus is your speed also. So you won't be like these only. When the bus is going in forward direction, you are not like this always. No. Temporarily you go back and then you are coming back here. Reason? Now you are also with the speed of the bus. So you are in agreement with that. That is called inertia of rest. चारों examples समझा? Lift at rest, lift moving up with uniform velocity, lift coming down with uniform velocity. You feel what you are. Lift going up with acceleration, you feel little heavy. Who makes you feel heaviness? Acceleration of the lift. Lift coming down with acceleration, you feel little loss in your weight. Lift falling down, you feel like a bird. You feel like an astronaut. You are weightless. Buoyant force का concept समझा? ये भी पूरा concept समझा? ये दोनों additional concepts थे. Additional, but very very useful. यहाँ तक समझा सबको? Now we are doing last 2 problems of the day. One is 29th and other is 33. Okay, one is 29 and other is 33. For just a moment. Okay. So are we on 29th problem, students? Are we on 29th problem, students? Are we on 29th problem, everyone? Okay, concentrate. In 29th problem, पहले 33rd कर लेते हैं because 33rd is exactly based on this. 33rd problem में everybody, this is a rigid support. Okay? This is the ball and this is the pendulum which is at rest. So right now nothing happens. But either I am pushing it, which is not possible over here because this is the wall. So I am pulling it. So when I pull it, this bob goes here. So how many forces do I have in all? Force number 1, students, who is this? W. Force number 2. Remember, tension always acts along the string. टेंशन फोर्स हमेशा कहाँ पे होता है? बॉडी से शुरू होता है, फिक्स पॉइंट की तरफ एक्ट करता है. हाँ, ये आपका फिक्स पॉइंट है. तो ये फोर्स कहाँ पे एक्ट करता है? बॉडी से शुरू होता है, फिक्स पॉइंट की तरफ एक्ट करता है। तो बॉडी और फिक्स पॉइंट के बीच में कौन है? रोप, वायर, स्ट्रिंग। सो वेर इज टेंशन फोर्स एक्टिंग? ऑलवेज अलोंग द स्ट्रिंग, रिमेंबर दैट। राइट, तीसरा फोर्स कौन सा हो गया? ध्यान से देखो बेटा, इज इट पी? पी का मतलब होता है पुल या तो पुश, टी का मतलब होता है टेंशन, डब्ल्यू का मतलब होता है वेट। और उन्होंने बाजू में ये डायग्राम दिया हुआ है, बाजू में ये डायग्राम दिया हुआ है। एज पर द डायग्राम बोल रहा हूँ बेटा मैं, एज पर द डायग्राम। उन्होंने जिस हिसाब से डायग्राम दे रहे हैं मैं उस हिसाब से जा रहा हूँ। अब उन्होंने ये तीनों वेक्टर सेपरेटली दिए हुए हैं, मैं नहीं दूंगा तो भी चलेगा, मैं दे दूंगा तो भी चलेगा। आप मुझे सिर्फ इतना बताओ, ये डायग्राम समझा? अभी क्या करने का? आपके पास जो भी फोर्सेस है रिवर्स डायरेक्शन में एक्सटेंड करो। सो 1 2 एंड 3। उन्होंने ये थीटा दिया है, ये। सो कॉमन सेंस अप्लाई करो, ये थीटा हुआ कि नहीं? कॉमन सेंस अप्लाई करो, ये थीटा हुआ कि नहीं? कॉमन सेंस अप्लाई करो। ये बंदा कौन हुआ? ये। और ये बंदा कौन हुआ? ये हुआ टी कॉस थीटा और ये हुआ। डायग्राम समझा? Now you have to apply your knowledge of Lamis theorem. You have to think about the common point where all the forces are acting, meeting point, right? And you have to compare right with left, up with down, front with back if it is there, northeast with southwest if it is there. In short, you have to compare right with left, up with down. Okay, this is that meeting point. So, tell me the equations. What should I write? What can you say about t cos theta? W. Very good. Can I say W and t cos theta balance each other?
Yes.
What can you say about t sin theta? Brilliant. Very good. P is equal to t sin theta. समझा बेटा? Let me call this as equation 1 and let me call this as equation 2. Is that clear? Sure. ये क्वेश्चन ओरिजिनली था IIT का। How many options or which of the following options are correct? मैंने इसको wrong change किया है क्वेश्चन, मैंने wrong करवाया इसको, क्योंकि अपने को एक ही आंसर चाहिए। One by one we have to crack this question, right? First one, ध्यान से देखो बेटा, if I go for equation 1 upon equation 2, what will I get? P upon W is equal to tan theta. इसका मतलब फर्स्ट ऑप्शन करेक्ट है, इसका मतलब फर्स्ट ऑप्शन करेक्ट है। सेकेंड ऑप्शन ओरिजिनली ऐसा है, t प्लस पी प्लस डब्ल्यू, ऑल दीज वेक्टर्स आर एडेड एज 0, लेकिन इसमें वेक्टर साइन होना कंपलसरी होता है। आई कैन नॉट राइट t प्लस डी प्लस डब्ल्यू इज इक्वल टू 0, वो तो एल्जीब्रा हो गया, मुझे वेक्टर एल्जीब्रा देखना है। सेकेंड ऑप्शन में छोटा सा मिसप्रिंट है, राइट हैंड साइड में 0 वेक्टर होना चाहिए, राइट हैंड साइड में 0 वेक्टर होना चाहिए। ओके, राइट हैंड साइड में 0 वेक्टर होना चाहिए, मतलब सेकंड स्टेटमेंट भी करेक्ट है। अभी थर्ड स्टेटमेंट ध्यान से सुनो, थर्ड स्टेटमेंट ध्यान से सुनो। व्हाट इफ आई स्क्वायर एंड ऐड इक्वेशंस 1 and 2? What if I square and add equations 1 and 2? What will I get? Will I not get p square plus w square is t square? सोचो बेटा, will I not get p square plus w square is t square? p square plus w square is t square sin square theta plus t square cos square theta. t square sin square theta plus t square cos square theta is t square. थर्ड ऑप्शन करेक्ट है। अब फोर्थ क्यों रॉन्ग है? क्योंकि सेकंड करेक्ट है। अगर सेकंड करेक्ट है बेटा तो p प्लस डब्ल्यू को नेगेटिव टी आना चाहिए, पॉजिटिव टी नहीं आना चाहिए। तो फोर्थ ऑप्शन में भी एक मिस्टेक है, सबके ऊपर वेक्टर साइन होना चाहिए। फोर्थ में भी मिस्टेक है, सबके ऊपर वेक्टर साइन होता है। अब जब देखो डीटीपी ऑपरेटर ये सब टाइप करता है ना, उसको ऊपर के एरो ऊपर की कैप का इंपॉर्टेंस नहीं मालूम होता। एंड टू बी वेरी ऑनेस्ट इट इज लिटिल रॉन्ग फ्रॉम आवर साइड आल्सो, एडिटिंग बराबर नहीं हुआ इसका, राइट? लेकिन उसमें भी सबके ऊपर वेक्टर साइन होना चाहिए। सेकंड वाज करेक्ट, दैट्स व्हाई फोर्थ इज रॉन्ग। फर्स्ट इज करेक्ट, मैंने प्रूव किया। सेकंड इज करेक्ट, मैंने प्रूव किया। थर्ड इज करेक्ट, मैंने प्रूव किया। फोर्थ इज रॉन्ग। मतलब आईआईटी के ओरिजिनल क्वेश्चन में ये था विच ऑफ द फॉलोइंग इज करेक्ट। 3 आंसर्स करेक्ट थे, एक रॉन्ग था। मुझे इसको नीट के हिसाब से, सीईटी के हिसाब से और जेडब्ल्यू मेंस के हिसाब से कन्वर्ट करना पड़ा, तो मैंने वो करेक्ट वर्ड को क्या कर दिया, विच वन इज रॉन्ग। अपना आंसर एक ही आया, एंड आवर आंसर इज दिल्ली। लामिस थियरम क्या बोलता है? इफ ऑल द फोर्सेस आर इन इक्विलिब्रियम देन सम ऑफ द फोर्सेस एट द मीटिंग पॉइंट इज ऑलवेज जीरो। तो बेटा ये मीटिंग पॉइंट हुआ ना। तेरे पास ओरिजिनली क्वेश्चन में 3 वेक्टर्स थे जो रेड से बनाए मैंने, ये और ये। तो अगर ये सब फोर्सेस इक्विलिब्रियम में हैं तो उनका टोटल जीरो होना चाहिए, नहीं तो बॉडी मूव होगा ना। फिर अगर नेट फोर्स जीरो नहीं है तो ये बॉडी मूव होगा। उन्होंने बोला है कि ये सिचुएशन है, मतलब ये बॉडी रेस्ट पे है अभी। आपको 33rd क्वेश्चन समझा बेटा? ओके, थर्ड वाला टी स्क्वायर, ओके P is t sin theta and W is t cos theta. So what is P square? T square sin square theta. Aman, is it visible now?
Yes, sir.
And what is W square? It is t square cos square theta. ऐड करो बेटा, आंसर आ गया। ऐड करो, आंसर आ गया। 33rd समझा सबको? हाँ, डिवाइड करके क्या करेगा तू? P स्क्वायर, हाँ, तो 1/2 किया तो ये आया ना। हाँ, तो वही किया था मैंने, वो फर्स्ट ऑप्शन करेक्ट लाने के लिए किया था। उसने मुझे सेकंड ऑप्शन पूछा है, थर्ड पूछा है, थर्ड। बराबर? हैव यू अंडरस्टूड 33rd क्वेश्चन स्टूडेंट्स? Very beautifully given in your notes. No need to copy anything. Last question of the day. Last question of the day. Will you please move on to 29th question? Will you please move on to 29th question? ध्यान से देखो बेटा, 2 रिजिड सपोर्ट दिया है, 2 रिजिड सपोर्ट दिया है, 1 and 2. What is the meaning of this symbol? Either it is a mirror or it is a rigid support, right? अब ध्यान से देखो, there are 2 strings, 1 and 2. There are 2 strings, 1 and 2, and there is a weight hanging over here. Correct? Weight hanging over here. Now this is the meeting point. एकदम ध्यान से सुनो, 1 by 1, और मुझे बोलते जाओ कि ये कौन है। Tell me who is this force? W. Proud of you. Who is this force? Tension. Because ये मीटिंग पॉइंट से एक्ट करता है फिक्स पॉइंट की तरफ। ये हो गया टेंशन। ये कौन हो गया? ये भी तो टेंशन ही हुआ ना, बिकॉज ये भी तो स्ट्रिंग है। लेकिन ये 2 टेंशन में से उन्होंने एक टेंशन दिया हुआ है। दिस इज 30 न्यूटन गिवन, चेक। ये हॉरिजॉन्टल वाला टेंशन दिया है उन्होंने 30, ये नहीं दिया है। And there are 2 questions asked. What is this tension? And what is this W? Okay. Now they have given me this angle. ध्यान से देखो बेटा, ये एंगल दिया उन्होंने मुझे, कितना है? 30 डिग्री। तो इसमें से मैं कौन से वेक्टर को रिजॉल्व कर सकता हूँ? ऑब्वियसली जिधर मुझे एंगल दिख रहा है, कौन सा वाला? मैं टी को रिजॉल्व कर सकता हूँ कि ये बाजू वाले टी को, कि डब्ल्यू को? ये वाले टी को, ये वाले टी को, क्योंकि वो टिल्टेड है। तो टेल मी दिस पैरेललोग्राम इज करेक्ट और नो? दिस पैरेललोग्राम इज करेक्ट और नो? करेक्ट। ये वाला ग्रीन कौन है? टी cos 30, और ये वाला ग्रीन कौन है? ए sin 30। अभी क्या करने का? अभी क्या करने का बोलो? Should we compare left with right, up with down, front with back? Left with right. So T sin of 30 degree is matching with 30. That means T into half is 30. So tension in the string कितना आया? 60 न्यूटन। ये मेरा एक आंसर हुआ। मुझे W भी तो ढूंढना है, So can I say T cos 30 is to be compared with W, और T मुझे यहां से मिल चुका है, That means 60 into root 3 by 2 is equal to W. So what is W? This is 30 root 3. तो आपका पहले कौन सा वर्ड है क्वेश्चन में? T के W? पहले कौन सा वर्ड है? W. So answer should be 30 root 3, 60. You know why? Sometimes they give very risky options. They give you 30 root 3, 60. They give you 60, 30 root 3. They give you 30, 60 root 3. They give you 60, 30 root 3. They give you something like this. So you have to be very careful. पहले कौन सा वर्ड था? वेट। तो पहले कौन सा आंसर आना चाहिए 32 कॉमा 60। हैव यू अंडरस्टूड द लेक्चर? इजी ना बेटा। W is balanced by T cos theta. Down with up. So W is equal to T cos theta. T मुझे मिल चुका है. Have you understood the lecture well? Extraordinarily important students. Please remember, I am going to upload this lecture on YouTube, and you should keep looking at this lecture again and again and again in future, because important in about 7 to 8 chapters of mechanics. This also. This will be important in friction and viscosity. This again will be equally important for 7 to 8. जहाँ पे भी lift का question आता है ना बेटा, वहाँ पे ये important, right? So we stop here for the day. Homework ध्यान से सुनो. Wait please.